Okay, guys, so over the last couple of days what we've done is we've done a brief introduction to the solar industry. We've looked at different types of opportunities. We took the panels outside, we looked at volts and we looked at amps. We took the lead acid battery, we measured the voltage, we charged it. In fact, that reminds me, we've just used it a bit, so what I'm going to do is I'm just going to plug it in so that we can start charging again. And the idea over the last couple of days have just really been to do a quick introduction on electricity and energy. We looked at a prepaid meter bill. We saw that we are billed in kilowatt hours. The charge we calculated, I think, was R3.82 per kilowatt hour. We are now at the point where we start looking at different types of systems. Where did I go with the cloth? So we are looking at different types of systems, and by different types of systems I'm talking about different types of solar systems. We haven't built a system yet, but what we've done, you just draw this on the board quickly. What we've done in the back is we've got a lead acid battery. We connected, those are the terminals over there. We connected an inverter to it. In the previous session, we connected a load to the inverter and we measured the amps. That was 230 volts. That was 12 volts. And what we also did on this side, we had a charger. We had an AC charger. And we connected it like that. That is the system in the way that we've got it in the back of the classroom. And that we've plugged into an Eskom supply. So far we've been able to charge the battery from the municipal supply, and we've been able to discharge the battery by using the inverter. Everybody happy? That's the system that we've got in the back over there. The next thing we are going to do is we are going to find a different way to charge the battery. By a different way, we could use a charge controller. We have the one charge controller we had a look at yesterday. This is the other charge controller. So there are different types of charge controllers we can use. The charge controllers I have over here are extremely cheap charge controllers. The more you pay for the charge controller, the more efficient they are. What I'm going to be doing next week is I will bring a hybrid inverter. I will show you guys what a slightly larger inverter looks like than the one that we've got in the back over there. So we've got an MPPT charge controller and we've got a PWM charge controller. When we discharge the battery, when I bring the light next week and we discharge the battery, we are going to use these controllers to recharge the battery. At the moment we are recharging from an Eskom supply. Next week we will be recharging using solar. Do you guys want to pass it around or are you happy? The one says MPPT. And the other one says PWM. You guys should be reading.
The other one says P what? WM.
PWM. Does it say PWM?
This one it says MPPTs and this one. What the? Yeah, that's why I'm like, I can't see it.
Those are USB plugs, and you'd be able to use the USB plug to charge a phone or charge a very small load. Guys, I know I've said this morning already, but if you read the label on the battery, some will say alkaline, some will say nickel metal hydride or NiMH, some say NiCad, some say lithium. So you've got to read what the different products are and how they work. These particular charge controllers are either PWM or MPPT. So that's the charge controller there. And over here I'm just going to write PWM charge controller, and that goes to a solar panel. I'm going to try and neaten up this drawing a little bit later. It looks really messy. So what we've got is an AC charger to charge the battery, or a charge controller to charge the battery, and the inverter that will be taking power out of the battery. Oh, you want to pass it over? There you go. The system that we've drawn on the board over here, if we don't have a municipal supply, are we going to be able to use an AC charger? In other words, would we be able to plug it in somewhere? We won't. So if we don't have a place to plug it in, that device is unnecessary because we are not going to be able to use it. So at the moment we just have the PWM charger and we have an inverter. This type of system we call off-grid. So when we talk about a grid, we are referring to the municipal infrastructure. Primarily, because the municipal infrastructure is referred to as a grid, and if we could charge this battery from the grid, it would not be an off-grid system. So at the moment, if we take this system and we take it to the homelands, or we put it somewhere else where there is no other available power, this system will be off-grid. If we add the charge controller back, I think what I'm going to do is I'm going to drop the battery slightly. So we've got our battery there. If we add the AC charge controller, now we are back in town. We've got an Eskom or a municipal supply. We want to be able to charge our battery, so now we get another charger, AC charger. And the AC charger charges the battery from Eskom. Years and years and years ago, about 10 years ago, we would, maybe even a bit more than that, 15 years ago, we would buy all three of these components as separate components. You would have to find an AC charger like we've got on the back there, or got in the, on the table in the back. You would have to find an inverter, and you'd have to find a charge controller, and you would build your own system. Then about 10 years ago, the guys decided, but wait a minute, why can't we just put all of these devices into one box? So they took all of these devices and they put it into one box, and they called it a hybrid. They called it a hybrid inverter. And when we look at hybrid inverters, I'll bring one on Monday. That was the big one I said I would bring. Let's see if there's internet. So on the screen, if you guys look at these inverters, I'm just going to click on one of these. That's what a hybrid inverter looks like. So a hybrid inverter consists of all three of those components built into the box. Hybrid inverters have come down in price substantially because the solar industry, well, there might be a number of reasons, but the solar industry at the moment is extremely quiet, so a lot of the suppliers have dropped their prices. So hybrid inverters at the moment are substantially cheaper than what they were 2 years ago. The most difficult thing about creating a solar system is understanding how to not wire the different components. Guys, yesterday we were busy with the battery there. You guys crimped plugs. You used heat shrink. So you managed to do a connection. Most of you have very little to no experience. But because you were guided through the process, you could crimp it, you could add the heat shrink, and the system is working. So the installation is one aspect, but you might be able to do the installation, but if you don't connect the equipment, the right type of equipment together, you're going to blow something up. So we need to know how many panels do we need to use. And that for me is almost the bigger question when you start doing solar installations. It's quite hot in here. We haven't even had lunch yet. You guys are looking very comfortable. Okay, so this is a hybrid inverter. This part of the course that we're covering says different types of systems. And before we start looking at the different types of systems, I want to explain them on the board first. Now, if we had, so we've covered off-grid, we've covered hybrid. The hybrid inverter, we said all three of these are in the same box. There's one more type of system. And the next system is a system that doesn't have a battery. So it has an inverter, it has solar panels, but it doesn't have a battery. It doesn't have an AC charger, and it doesn't need one because it doesn't have a battery. Which one is this one? Which one is this one? So this one you can only really do when you have a grid available. So you have the Eskom supply, you have the solar, and you have the inverter, and this system is called a grid tied. System. So there we have our three systems on the board. We have an off-grid system, we have a grid-tied system, and we have a hybrid. I see you guys are still writing. I'm going to leave you to just finish writing. writing first before we continue. Off grid tie and hybrid. What's wrong?
I'm good for my parents.
Oh yes. Off grid tied and hybrid. So what's the catch here? With a grid-tied system, why would you have the different systems? With a grid-tied system, you would supply a grid-tied system to guys who don't have batteries. To guys who don't need batteries. Why would you not need batteries? At the moment, do we have load shedding?
No.
We don't have load shedding. So because we don't have load shedding, guys don't have to spend money on batteries. Yeah. Okay. I'm going to explain it differently. Do you guys remember what we said the cost of prepaid power was? You guys remember how much was it? 3 Rand, was it 2 Rand 83 or 3 Rand 82? 382. So if our electricity is costing 3 Rand 82, if we can buy electricity from somewhere else that is cheaper, we are going to be saving. So if we have a solar system, and I'm going to draw the grid-tied solar system, I'm going to draw slightly differently. Yesterday we spoke about transformers. You missed out. Anyway, you missed out on the section on transformers. I'll cover transformers again a little bit later. So you've got the Eskom supply, and at the moment you've got your house loads. At the moment you've got all of the stuff inside your house sits over here. Your meter sits there. So you've got a meter, you've got a DB board. This is what your existing electrical installation looks like. The transformer sits outside in the street. Most of you might not even know where the transformer sits or where your power is coming from. It's not an issue because you can't really see where the wires are going. You might see the different transformers, maybe it's up on a pole, maybe it's in the street. Could be in a number of places. So it would go from the transformer through the meter, through the DB board, and it would power the kettle, whatever load you have in the house. This, at the moment, is costing you 3 Rand 82 per kilowatt hour. If we had that doesn't look very nice. This rectangular block with a line running through it is how we draw an inverter. So if we had an inverter connected to solar, the inverter would generate electricity, it would push it into the DB board, and your house will be using the power coming from the solar. Guys, you can't use that inverter we've used over there. That one, the black one. So you can't use that black inverter here. Because the inverter that you use here, remember when we were with the battery standing next to the battery earlier on, I said that alternating current as a wave. You remember that? So the alternating, the inverter over here has a wave, and the Eskom supply as a wave. So this inverter has to be able to match the wave, the red wave, to the black wave. Does any of this make sense? Not really. Have I lost you guys somewhere? Then D-Way, it looks like you are far, far away.
No, like I'm trying to.
Okay, so early in the morning, this inverter is sleeping before the sun comes up. The inverter falls asleep in the evening when the sun goes down, and it wakes up in the morning when the sun comes up. When this inverter wakes up, it starts looking for the signal. It wants to see what Eskom signal looks like. As soon as it has seen what the signal looks like, it tries to copy that signal. I call it the grid's fingerprint. So the grid has a fingerprint. When this inverter wakes up, it starts looking for this fingerprint and it wants to copy it. As soon as it has copied it, it synchronizes. It holds onto the fingerprint of the grid. And as soon as it has something to hold onto, as long as it has something to hold onto, it will be able to push power into the DB board. Yo, guys, where are we today? It's day 4. You guys look very tired today.
We are not tired, you're just paying attention.
Maybe because you had the day off yesterday. You are energized. I'm wondering, what do we do? Do we make shorter sessions? Shall we take a quick break? Okay, cool. Let's take a quick break. Guys, we do have time to work through this, so I'm not stressed about the rate at which we are going through the work. But it's not going to help. I kind of work through the work and I'm losing you guys halfway.